The application of integration by substitution follows a similar procedure for indefinite and definite integrals, except in one step. In general, in both cases, we will need to obtain the values of u and du and replace all factors in function of u and du, and then integrate. However, for the case of indefinite integrals, once we finish the integration, we will need to reverse back all terms to be a function of x again. Let's solve this example to illustrate how we proceed when we have an indefinite integral. In order to apply integration by substitution, we need to identify some characteristics in the integration. First, we must have two factors that are multiplying each other. In this case, we have 6x squared and x to the third plus 4. In that sense, one of them will be our u. One way to recognize which one will be our u is that generally we choose as u the most complex factor between 6x squared, which is a quadratic function, and x to the third plus 4. The most complex function is the second one. This means that x to the third plus 4 will be our u. Then we take the derivative of u with respect to x. This is 3x squared. Here we can reorganize terms, and we have that dx is equals to du divided by 3x squared. And this is the relation that we will need in order to transform dx into du. Now let's proceed to replace all factors as a function of u and du. Let's copy our original integral first. Notice that this is u. I will put it in the front. In this case, it's u to the first exponent because here in this particular case there is no square or to the third, it's just to the 1. Times the remaining term is 6x squared times dx. But dx is equals to du divided by 3x squared. From here, we can cancel x squared and x squared. And 6 divided by 3 is 2. And here we can see something pretty important. we know that we chose correctly our u if, when we replace u and the u, there are no expressions using functions of x. Notice that here everything is a function of u. Now that we have our integral to u du, we can proceed with the integration. Notice that I can't take the constant out. This is 2 times the integral of u is u squared divided by 2, which we have done that before. What we normally do is that we add 1 unit to the exponent, so 1 plus 1 is equals to 2, and we divide the whole term by the new exponent, which is 2. And because this is an indefinite integral, we need to add plus c. Notice from here that we can simplify 2 and 2. This means that this becomes u squared plus c. In our last step, we need to replace back in other words, because u was x to the third plus 4, the integration is x to the third plus 4 everything squared plus c. And this is our answer. And this is because the original problem was a function of x. Therefore, the solution must also be a function of x.